Hello everyone, welcome to National Standard Examination in Physics 2017. Consider two point masses m1 and m2 connected by a light rigid rod of length r0. The moment of inertia of the system about an axis passing through their center of mass and perpendicular to the rigid rod is given by distance of the first particle from the axis of rotation r1 equal to m2 by m1 plus m2 into r0. Distance of the second particle from axis of rotation r2 equal to m1 by m1 plus m2 into r0. Moment of inertia of the first particle m1 r1 square, that is m1 times m2 by m1 plus m2 into r0 whole square. Moment of inertia of the second particle m2 r2 square, that is m2 times m1 by m1 plus m2 into r0 whole square. The total moment of inertia I equal to m1 r1 square plus m2 r2 square, which comes out to be m1 m2 by m1 plus m2 into r0 square. Motion of a particle in a plane is described by non-orthogonal set of coordinates p, q with unit vectors p cap and q cap inclined at an angle theta as shown in figure. If the mass of the particle is m, its kinetic energy is given by. In this problem, x dot is defined as dx by dt. Position vector of the particle r bar equal to p into p cap plus q into q cap. Velocity vector of the particle v bar equal to dr bar by dt, that is dp by dt p cap plus dq by dt q cap. Taking the dot product of velocity vector v bar dot v bar equal to dp by dt p cap plus dq by dt q cap dot dp by dt p cap plus dq by dt q cap. Multiplying throughout with half m, we have half mv square equal to half m dp square by dt plus dq square by dt plus 2 p dot q dot cos theta. So the kinetic energy is p dot square plus q dot square plus 2 p dot q dot cos theta. A man is going in a lift open at the top, moving with a constant velocity 3 meter per second. He throws a ball up at 5 meter per second relative to the lift when the lift is 50 meter above the ground. Height of the lift when the ball meets its during downward journey is, take g 10 meter per second square. Velocity of the ball with respect to lift VBL equal to VB minus VL, that is 5 meter per second. So VB equal to VL plus 5, that is 8 meter per second. Time of ascent of the ball VB by G, that is 8 by 10.8 seconds. Maximum height reached by the ball VB square by 2G, that is 3.2 meter. Distance traveled by the lift during the upward journey of the ball is 2.4 meter. The ball will meet the lift during its downward journey. The lift is still moving up. For time of contact, 3.2 minus 2.4 equal to 0.8, that is v1t plus half gt square. 0.8 equal to 3t plus 5t square, which gives us t equal to 0.2 seconds. Distance traveled by the lift during this time is 3 into 0.2, that is 0.6 meter. So the total height of the lift is 50 plus 2.4 plus 0.6, that is 53 meter. When a body is suspended from a fixed point by a spring, the angular frequency of its vertical oscillations is omega 1. When a different spring is used, the angular frequency is omega 2. The angular frequency of vertical oscillation when both the springs are used together in series is given by angular frequency of vertical oscillations of a spring block system omega equal to 2 pi by t, that is root k by m. Omega 1 equal to root k1 by m, from where k1 equal to omega 1 square m. Omega 2 equal to root k2 by m, from where k2 equal to omega 2 square m. Omega equal to root of k series by m, that is series equal to omega square m. K series equal to k1 k2 by k1 plus k2. So omega square m equal to omega 1 square m omega 2 square m by omega 1 square m plus omega 2 square m, which gives us omega equal to omega 1 square omega 2 square by omega 1 square plus omega 2 square whole power 1 by 2. A small pond of depth 0.5 meter deep is exposed to a cold winter with outside temperature of 263 Kelvin. Thermal conductivity of ice is 2.2 watt per meter Kelvin. Latent heat of ice is 3.4 into 10 power 5 joule per kg. and density of ice is 0.9 into 10 power 3 kg per meter cube. Take the temperature of pond to be 273 K. The time taken for the whole pond to freeze is about. Time taken to freeze the pond T equal to 1 by 2 rho L by KT into y square, where y is the thickness of the ice layer. Substituting the given numerical data into the formula, we have T equal to 20 days. A body of mass 4 kg moves under the action of a force 4I plus 12Tj Newton, where T is time in seconds. The initial velocity of the particle is 2I plus j plus 2k meter per second. If the force is applied for 1 second, work done is impulse imparted by a variable force integral 0 to 1 f dt equal to delta p, that is m of v minus u. Integral 0 to 1 4i plus 12t square j dt equal to 4 into v minus 2i plus j plus 2k. So it is 4ti plus 12t cube by 3j equal to 4v minus 8i plus 4j plus 8k, which gives v equal to 3i plus 2j plus 2k. Applying work energy theorem, work done equal to change in kinetic energy. It is a half m into v square minus u square. So it is a half into 4 into 17 minus 9, that is 16 joule. A racing car moves along a circular track of radius b. The car starts from rest and its speed increases at a constant rate alpha. Let the angle between the velocity and acceleration be theta at a time t, then cos theta is. As the car is moving along the circular path, velocity is always tangential. Rate of increase in speed is tangential acceleration. At is given to be alpha. Speed of the particle at t seconds, v equal to u plus at, that is 0 plus at, that is alpha t. Centripetal acceleration ac equal to v square by b, that is alpha square t square by b. So the resultant acceleration a equal to root of ac square plus at square, because centripetal acceleration and tangential acceleration are always perpendicular to each other. So the resultant acceleration comes out to be root of a power 4 t power 4 by b square plus alpha square. Angle between velocity and acceleration cos theta equal to v by a, that is alpha t by root of alpha power 4 t power 4 by b square plus alpha square, that is effectively bt by b square plus alpha square t power 4 whole power 1 by 2. A small fish 4 cm below the surface of a lake is viewed through a thin convergent lens of focal length 30 cm and held 2 cm above the water surface. Refractive index of water is 1.33. The image of the fish from the lens is at a distance of. Apparent depth of the fish dA equal to d by mu, that is 4 by 4 by 3, which is 3 cm, which becomes the object distance for the lens. Applying lens formula, 1 by v minus 1 by u equal to 1 by f, that is 1 by v plus 1 by 5 equal to 1 by 30, which gives v equal to minus 6 cm. A horizontal ray of light passes through a prism of refractive index 1.5 and apex angle 4 and then strikes a vertical plane mirror placed to the right of the prism. If after reflection the ray is to be horizontal, then the mirror must be rotated through an angle. Deviation produced by the prism delta equal to mu minus 1 of a, that is 1.5 minus 1 of 4, 2 degrees. This light ray falls on the plane mirror at an angle of incidence. For the reflected ray to be horizontal, it has to be deviated by 2 degrees. So the mirror is to be rotated by 1 degree clockwise. An isolated metallic object is charged in vacuum to a potential V0 using a suitable source. Its electrostatic energy being W0. It is then disconnected from the source and immersed in a large volume of dielectric with a dielectric constant K. The electrostatic energy of the sphere in the dielectric is. Electrostatic energy W0 equal to half Q V0. When the charged object is placed in dielectric, the new potential V equal to V0 by K. Charge remains same as the object is disconnected from the source. So the new electrostatic energy W equal to half QV, that is a half Q V0 by K, which is W0 by K. Two identical coils, each of self-inductance L, are connected in series and are placed so close to each other that all the flux from one coil links the other. The total self-inductance of the system is series combination of inductors L equal to L1 plus L2 plus or minus 2M. M is mutual induction, which can be written as K times root L1 L2, where K is coefficient of coupling. Since all the flux from the first coil links the second coil, we can write K equal to 1. So L equal to L1 plus L2 plus 2K root L1 L2, which is L plus 2L, which is 4L. A coil 2 cm in diameter has 300 turns. If the coil carries a current of 10 mA and lies in a magnetic field 5 into 10 power minus 2 Tesla, the maximum torque experienced by the coil is torque on current carrying coil tau equal to mb sin theta. Maximum torque tau max equal to mb, that is IAN into B, I into pi d square by 4 into n into B. So tau max equal to 10 into 10 power minus 3 into pi into 0.02 whole square by 4 into 300 into 5 into 10 power minus 2, which is 4.7 into 10 power minus 5 Newton meter. A particle performs simple harmonic motion at frequency f. The frequency at which its kinetic energy varies is frequency of oscillation of the particle is f. Displacement of the particle in SHM is given by x equal to a cos omega t, that is a cos 2 pi ft. Velocity of the particle in SHM v equal to dx by dt, that is minus a omega sin omega t, that is minus a omega sin 2 pi ft. Kinetic energy of the particle k equal to half mv square, that is a half m minus a omega sin 2 pi ft whole square. So k equal to half m omega square a square sin square 2 pi ft, k max sin square 2 pi ft, k max of 1 minus cos 2 times 2 pi ft. So the frequency of oscillation of the kinetic energy is 2f. In case of real images formed by thin convex lens, the linear magnification is directly proportional to the image distance, inversely proportional to the object distance, directly proportional to the distance of the image from the nearest principal focus, inversely proportional to the distance of the object from the nearest focus. For real image formed by convex lens, 1 by v minus 1 by u equal to 1 by f. Here u is negative and v is positive. So it is 1 by v plus 1 by u equal to 1 by f. Multiply throughout with v, we have 1 plus m equal to v by f, from where m equal to v minus f by f. On similar lines, we can express magnification in terms of u, which is m equal to f by u minus f. Let the distance from the focal length be x, so that we can write u equal to f plus x and v equal to f plus x. So ultimately we have m equal to v minus f by f, that is f plus x minus f by f, that is x by f. In terms of u, m equal to f by u minus f, that is f by f plus x minus f, which is f by x. So statements 3 and 4 are correct. An infinitely long straight non-magnetic conducting wire of radius A carries a DC current I. The magnetic field B at a distance R, which is less than A, from the axis of the wire is. Figure shows the cross-sectional view of the conductor. Applying Ampere's rule, magnetic field inside the conductor at a distance R, which is less than A, integral b bar dot dl bar equal to mu naught I, that is b into 2 pi r equal to mu naught I. Here small I is the current flowing through the given cross section, which we have to express in terms of capital I. Taking uniform current density, we can write small I equal to capital I into r square by a square. So b equal to mu naught I r by 2 pi a square. A quantity alpha is defined as alpha equal to E square by 4 pi epsilon naught C h by 2 pi, where E is electric charge, h is Planck's constant and c is speed of light. The dimensions of alpha are given E square by 4 pi epsilon naught C h by 2 pi, which can be rearranged as E square by 4 pi epsilon naught 2 pi by hc. E square by 4 pi epsilon naught can be written as fr square. 2 pi by hc can be written as 2 pi by E lambda, where E is energy and lambda is wavelength. So the dimensional formula becomes m naught, L naught, T naught, I naught. So the given expression is a dimensionless quantity. The Earth's magnetic field at certain point is 7.0 into 10 power minus 5 Tesla. This field is to be balanced by a magnetic field at the center of the circular current carrying coil of radius 5 cm by suitably orienting it. If the coil has 100 turns and then required current is about. Earth's magnetic field B Earth equal to 7.0 into 10 power minus 5 Tesla. Magnetic field at the center of the circular coil B equal to mu naught In by 2R. That is 4 pi into 10 power minus 7 into I into 100 by 2 into 0.05, which is 4 pi into 10 power minus 4 I. Both the fields should balance each other, so BE equal to B, 7 into 10 power minus 5 equal to 4 pi into 10 power minus 4 I, which gives us the current value to be approximately 56 milliampere. The equation correctly represented by the following graph is, here A and B are constants. The graph is a straight line with a positive slope and a positive y-intercept. So we can write it as y equal to mx plus c. So log y equal to m log x plus c. Here m is slope and c is y-intercept. From there we can write y equal to e power ln x power m plus c, which gives us y equal to e power ln x power m into e power c, which is in the form of y equal to a into x power b. Which one of the following devices does not respond to the intensity of light incident on it? A photoresistor, that is a light dependent resistor, photodiode, light emitting diode, and a solar cell. The resistance of a photoresistor depends on intensity of light. The current given by the photodiode depends on intensity of light. The potential difference developed by a solar cell depends on intensity of light. So, a light emitting diode does not respond to the intensity of light incident on it because a light emitting diode emits light by itself. Consider a parallel plate capacitor. When half of the space between the plates is filled with some dielectric material of constant K as shown in figure 1 below, the capacitance is C1. However, if the same dielectric material fills half of the space as shown in figure 2, the capacitance is C2. Therefore, the ratio C1 is to C2 is, in the first case, it becomes a series combination of two capacitors, 1 by C1 equal to 1 by C0 plus 1 by Ck. 1 by C1 equal to d by 2 epsilon naught A plus d by 2 k epsilon naught A. Since the dielectric material divides the distance between the two plates into two halves, we write d by 2 for each capacitor. Effectively, it is C1 equal to 2 epsilon naught A by d into k by k plus 1. In case 2, it is a parallel combination of capacitors. The dielectric divides the area between the two plates into two halves. So C2 equal to C0 plus Ck, epsilon naught A by 2d plus k epsilon naught A by 2d, epsilon naught A by 2d of 1 plus k. Taking the ratio, C1 is to C2 equal to 4k by k plus 1 whole square. A point source of light is viewed through a plate of glass of thickness T and refractive index 1.5. The source appears closer by a distance 2t by 3, closer by a distance t by 3, farther by a distance t by 3, farther by a distance 2t by 3. You can see the diagram. Apparent shift t of 1 minus 1 by mu, that is t of 1 minus 2 by 3, which is t by 3. So, the source appears to be closer by t by 3. The fraction of the original number of nuclei of radioactive atom having a mean life of 10 days that decays during the 5th day is mean life of the radioactive sample tau equal to 10 days, decay constant of the radioactive sample lambda equal to 1 by tau, that is 1 by 10. Number of decays during 5th day is number of atoms on day 4 minus number of atoms on day 5, that is n0 e power minus 4 lambda minus n0 e power minus 5 lambda, which is n0 e power minus 2 by 5 minus e power minus 1 by 2. The fractional number of nuclei decaying in 5th day, n4 minus n5 by n0, that is e power minus 2 by 5 minus e power minus 1 by 2, which comes out to be 0.064. The photoelectric threshold wavelength of tungsten is 230 nanometer. The energy of the electrons ejected from its surface by ultraviolet light of wavelength 180 nanometer is. Threshold wavelength of tungsten lambda naught equal to 230 nanometer. Wavelength of the incident radiation is 180 nanometer. Applying Einstein's photoelectric equation E equal to 5 plus k max. Hc by lambda equal to hc by lambda naught plus k max, which is hc of 1 by lambda minus 1 by lambda naught equal to k max. So 1240 times 1 by 180 minus 1 by 230 equal to 1.5 electron volt. A slit of width A is illuminated by parallel monochromatic light of wavelength lambda. The value of A at which the first minimum of diffraction pattern will form at theta equal to 30 is. Condition for diffraction minima, A sin theta equal to m lambda, so A sin theta equal to 1 into lambda, so A equal to 2 lambda. A vessel whose air column is open at both ends has a fundamental frequency of 500 Hz. The vessel is dipped in water such that half of it remains out of water. What will be the fundamental frequency now? Speed of sound in air is 340 meter per second. Fundamental frequency of open pipe V by 2L, that is 500 Hz. When the pipe is dipped in water to half of the depth, length of the closed pipe is L by 2. Fundamental frequency of closed pipe is V by 4LC, that is V by 4 into L by 2, that is again V by 2L, which is 500 Hz. So there is no change in frequency. The physical quantity that has unit of volt second is. Let us go by option verification method. Dimensional formula of volt second. Volt can be written as work by charge. So its dimensional formula is ml square t power minus 2 I power minus 1. Dimensional formula of energy is nothing but that of work. So ml square t power minus 2. Dimensional formula of electric flux is q by epsilon naught ml cube t power minus 3 I power minus 1. Dimensional formula of magnetic flux B into A ml square t power minus 2 I power minus 1. Dimensional formula of inductance phi B by I, that is ml square t power minus 2 I power minus 2. So the correct option is 3. Consider different orientations of a bar magnet lying in a uniform magnetic field as shown below. The potential energy is maximum in orientation. Potential energy of a magnet in uniform magnetic field U equal to minus m bar dot b bar, that is minus mb cos theta. Magnetic moment is directed from south pole to north pole. In figure 2, m and b are opposite to each other, so theta is 180. So U max equal to minus mb cos 180, that is mb. Two identical charged spheres suspended from a common point by two light strings of length L are initially at a distance d which is very much less than L apart due to their mutual repulsion. The charges begin to leak from both the spheres at constant rate. As a result, the spheres approach each other with a velocity v. If x denotes the distance between the spheres, then v varies as. For equilibrium of the charges, Fx equal to Fe minus t sin theta. So Fe minus t sin theta equal to 0. So Fe equal to t sin theta. Fy equal to t cos theta minus mg. T cos theta minus mg equal to 0. So mg equal to t cos theta. From both the equations, we have tan theta equal to Fe by mg. X by 2L equal to kq square by x square mg, which gives x cube equal to 2lk by mg into q square, which is q equal to k dash x power 3 by 2, where k dash is a constant. Differentiating with respect to time, 3x square dx by dt equal to k into 2q dq by dt. So v equal to 2k by 3 q x power minus 2 dq by dt, that is 2k by 3 k dash x power 3 by 2 x power minus 2 dq by dt, which is k double dash x power minus 1 by 2 dq by dt, from which we can write v proportional to x power minus 1 by 2, since dq by dt is constant. A network of 6 identical capacitors, each of capacitance C, is formed as shown below. The equivalent capacitance between the point A and B is. Given circuit diagram can be redrawn as shown in figure. Capacitance between A and D is 2C and that between E and B is also 2C. So the effective capacitance between A and B, CAB equal to 2C by 3 plus 2C by 3, which is 4C by 3. A cylinder on whose surface there is a vertical electric field of varying magnitude as shown. The electric field is uniform on the top surface as well as on the bottom surface. Therefore, this cylinder encloses no net charge, net positive charge, net negative charge. There is not enough information to determine the charge. Applying Gauss theorem, phi net equal to E net into A, that is 800 minus 400 into A, that is 400A. Phi net also can be written as Q in by epsilon naught. So Q in equal to phi net into epsilon naught. So it is 400A epsilon naught. So the net charge inside the closed surface Q in equal to 400A epsilon naught. Two identical solid blocks A and B are made up of two different materials. Block A floats in a liquid with a half of its volume submerged. When block B is pasted over A, the combination is found to just float in the liquid. The ratio of densities of the liquid, material A and material B is given by. For flotation of A, MAG equal to FB, that is V into dA into G equal to V by 2 into D liquid into G, which gives D liquid equal to 2 times dA. For flotation of A and B together, MAG plus MBG equal to 2V D liquid G. So VG into dA plus dB equal to 2V D liquid G. There we have D liquid equal to dA plus dB by 2. So dB equal to 2 times D liquid minus dA, that is 3 times dA. So D liquid to dA to dB equal to 2 dA, dA, 3 dA, that is 2:1:3. In an X-ray tube, the electrons are expected to strike the target with a velocity that is 10% of velocity of light. The applied voltage would be speed of the electron V equal to 10% of C, that is 0.1 into 3 into 10 power 8, that is 3 into 10 power 7 meter per second. Electrons acquire this speed due to work done by the electric field applied between the cathode and anode. Applying work energy theorem, W net equal to delta K, that is K final minus K initial. Half m v square minus u square, that is half m v square minus 0, that is half m v square. Work done by electric field W equal to qv, that is E into V. Here the charge of the electron is represented with a small e. So EV equal to half mv square, which gives V equal to V square by 2 times E by m. So 3 into 10 power 7 whole square by 2 into 1.76 into 10 power 11, which is 2.559 kilovolt. When observed from the earth, the angular diameter of sun is 0.5 degree. The diameter of the image of the sun when formed in a concave mirror of focal length 0.5 meter will be about. Here object distance is infinity. Applying mirror formula, 1 by V plus 1 by U equal to 1 by F, which gives V equal to F. From the diagram, tan theta equal to AB by PF. For small angles, tan theta can be replaced with theta. So theta equal to diameter of the image by focal length. So the diameter of the image equal to theta F. So the diameter of the image 0.5 into pi by 180 into 500, that is 4.4 millimeter. The decimal number that is represented by the binary number 1000111.101 base 2 is. The given binary number 1000111.101 base 2. Applying binary to decimal conversion, 1 into 2 power 5 plus 0 into 2 power 4 plus 0 into 2 power 3 plus 0 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0 plus 1 into 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3, which is 35.625. The excess pressure inside a soap bubble is equal to 2 mm of kerosene of density 0.8 gram per cc. If the diameter of the bubble is 3 cm, the surface tension of the soap solution is. Excess pressure in a soap bubble delta P equal to 4T by R. Pressure due to liquid column P equal to H rho g, that is 2 into 10 power minus 3 into 800 into 9.8, which is 15.68 Newton per meter square. Given delta P equal to P, 4T by R equal to 15.68, which gives us the surface tension of the soap solution to be 58.8 dyne per centimeter. Let V and I be the readings of voltmeter and ammeter respectively as shown in figure. Let RV and RA be their corresponding resistances. Therefore, reading of the voltmeter V equal to I into R effective, that is V equal to I into R RV by R plus RV. So V by I equal to R RV by R plus RV. I by V equal to R plus RV by R RV, which is 1 by R plus 1 by RV. So 1 by R equal to I by V minus 1 by RV. From there we get R equal to 1 by I by V minus 1 by RV. A man stands at rest in front of a large wall. A sound source of frequency 400 Hz is placed between him and the wall. The source is now moved towards the wall with a speed of 1 meter per second. The number of beats heard per second will be, speed of sound in air is 345 meter per second. Frequency received by the wall, N wall equal to V by V minus Vs into N, that is 345 by 344 into 400, 401.16 Hz. Frequency received by the driver, N driver equal to V plus V naught by V into NW, that is 346 by 345 into 401.16, that is 402.3. Number of beats heard by the driver delta N equal to N driver minus N, 402.3 minus 400, that is 2.32. A hollow sphere of inner radius 9 cm and outer radius 10 cm floats half submerged in a liquid of specific gravity 0.8. The density of the material of the sphere is. Let the density of the material be rho. For equilibrium of floating body, gravitational force equal to buoyancy force, mg equal to V in into rho liquid into g, that is 4/3 pi r cube minus small r cube into rho equal to 2 by 3 pi r cube into rho liquid. 542 rho equal to 1000 into 0.8, which gives us rho equal to 1.48 gram per cc. Rays from an object immersed in water mu equal to 1.33 traverse a spherical air bubble of radius r. If the object is located far away from the bubble, its image as seen by the observer located on the other side of the bubble will be. The air bubble in water acts as concave lens, so the final image formed by the lens is virtual, erect and diminished. A 10 ohm resistor is connected to a supply voltage alternating between plus 4 volts and minus 2 volt as shown in figure. The average power dissipated in the resistor per cycle is. Average power P average equal to 1 by T integral 0 to T P dt, that is 1 by T integral 0 to T Vi dt. P average equal to 1 by T integral 0 to T V square by R dt, that is 1 by TR integral 0 to T V square dt. Since voltage time graph is given, we have written the formula for power in terms of voltage. P average equal to 1 by 10 into 0.2 integral 0 to 0.1 16 dt plus integral 0.1 to 0.2 4 dt, that is 1 by 2 times 16 of 0.1 minus 0 plus 4 of 0.2 minus 0.1, which gives us the average power to be 1 watt. In the following arrangement, the pulley is assumed to be light and strings inextensible. The acceleration of the system can be determined by considering conservation of certain physical quantities. The physical quantity conserved and acceleration respectively are. Here, total mechanical energy is conserved. Change in potential energy equal to change in kinetic energy, that is 3 plus 1 gx minus 2 gx equal to half into 3 plus 1 plus 2 v square, that is 2gx equal to 3v square. Differentiating with respect to time, 2g into dx by dt equal to 3 into 2v into dv by dt, from which we get a equal to g by 3. Two cells each of EMF E and internal resistances R1 and R2 respectively are connected in series with an external resistance R. The potential difference between the terminals of the first cell will be 0 when R is equal to current flowing through the circuit I equal to 2E by capital R plus R1 plus R2. Potential difference across the terminals of the first cell V1 equal to E minus IR1. So 0 equal to E minus IR1, which gives us E equal to IR1. So E equal to 2E by R plus R1 plus R2 into R1, which is capital R equal to R1 minus R2. A student uses a convex lens to determine the width of a slit. For this, he fixes the positions of the object and the screen and moves the lens to get a real image on the screen. The images of the slit are found to be 2.1 cm and 0.48 cm wide respectively when the lens is moved through 15 cm. Therefore, the slit width and the focal length of the lens respectively are size of the object O equal to root I1 I2, that is root of 2.1 into 0.48, which is 1 cm. For the first image, I1 by O equal to 2.1 by 1, that is 2.1, which also can be written as V1 by U. Here we are writing the formula for magnification equal to 2.1, so V1 equal to 2.1 U. Given V1 minus U equal to 15, 2.1 U minus U equal to 15, which gives U equal to 13.6 cm. Applying lens formula, 1 by V minus 1 by U equal to 1 by F, 1 by 2.1 U plus 1 by U equal to 1 by F, which gives us F equal to 9.3 cm. In the following circuit, the current is in phase with the applied voltage. Therefore, the current in the circuit and frequency of the source voltage respectively are. Given that the current is in phase with the applied voltage, that is phase difference is 0, this is possible only when the circuit is in resonance. So at resonance, power factor is 1, that is cos phi equal to 1. Under resonance, an LCR circuit behaves as a pure resistive network. So the current flowing through the circuit I equal to V by R. For resonant frequency, we can equate inductive reactance and capacitive reactance. XL equal to XC, omega L equal to 1 by omega C, which gives us F equal to 1 by 2 pi root LC. In an atom, an electron excites to the fourth orbit. When it jumps back to the lower energy level, a spectrum is formed. The total number of spectral lines in this spectrum would be. When an electron gets back to its original state, it can do so in different ways as shown in figure. Number of spectral lines is the number of ways of de-excitation, that is n into n minus 1 by 2. Here n is 4. So we get number of possibilities to be 6, but since there is only one atom, the number of spectral lines possible is 3. The following figure shows the section ABC of an equilateral triangular prism. A ray of light enters the prism along LM and emerges along QD. If the refractive index of the material of the prism is 1.6, angle LMN is. Apply Snell's law at Q. 1 into sin 90 equal to mu sin theta, that is sin theta equal to 1 by mu, theta equal to 38.68 degree. From the triangle MBQ, 60 plus 90 minus R plus 51.32 equal to 180, which gives R equal to 21.32. Applying Snell's law at M, 1 into sin I equal to mu into sin R, sin I equal to 1.6 into sin 21.32, that is 0.58. From there I equal to sin inverse 0.58, which is 35.45 degree. A ball of mass m hits directly another ball of mass capital M at rest and is brought to rest by impact. 1/3 of the kinetic energy of the ball is lost due to collision. The coefficient of restitution is. Applying conservation of momentum, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, that is mu equal to capital M into v, which is v by u equal to m by capital M. Initial kinetic energy of the system k initial equal to p initial square by 2m, that is mu whole square by 2m, that is mu square by 2. Final kinetic energy of the system k final equal to p final square by 2m, that is mv whole square by 2m, that is capital M v square by 2. Loss in kinetic energy delta k equal to k initial minus k final, that is 1 by 3 k initial. So k final equal to 2 by 3 k initial. mv square by 2 equal to 2 by 3 times mu square by 2, which gives us v by u equal to 2 by 3. Coefficient of restitution E equal to v minus 0 by u minus 0, that is v by u, that is 2 by 3. An object 1 cm long lies along the principal axis of a convex lens of focal length 15 cm, the center of the object being at a distance of 20 cm from the lens. Therefore, the size of the image is. Applying lens formula, 1 by v minus 1 by u equal to 1 by f, 1 by v plus 1 by 20 equal to 1 by 15, which gives v equal to 60 cm. Linear or transverse magnification m equal to size of the image by size of the object, which is also equal to image distance by object distance. Longitudinal magnification m dash equal to v square by u square, that is 60 square by 20 square, which is 9. So the size of the image I equal to m dash into o, that is 9 cm. Acidified water from certain reservoir kept at a potential V falls in the form of small droplets, each of radius small r, through a hole into a hollow conducting sphere of radius a. The sphere is insulated and is initially at zero potential. If drops continue to fall until the sphere is half full, the potential acquired by the sphere is. Potential of each droplet V equal to 1 by 4 pi epsilon naught q by r. Number of droplets in the insulated sphere is n into 4/3 pi small r cube, that is 2 by 3 pi a cube, which gives n equal to a cube by 2r cube. So the potential acquired by the sphere V dash equal to 1 by 4 pi epsilon naught n cube by a, that is 1 by 4 pi epsilon naught q by a times a cube by 2r cube, which is a square by 2r square into capital V. Since potential is a scalar quantity, we have gone for algebraic addition. The series combination of a variable resistance R, 100 ohm resistance and a moving coil galvanometer is connected to a mobile phone charger having negligible internal resistance. The zero of the galvanometer lies at the center and the pointer can move 30 division full scale on either side depending on the direction of current. The reading of the galvanometer is 10 divisions and the voltage across the galvanometer and the 100 ohms resistor are respectively 12 millivolt and 16 millivolt. The figure of merit of the galvanometer in microampere per division is. Potential drop across 100 ohm resistor is 16 millivolt. Applying V equal to IR, we can find I equal to 16 into 10 power minus 5 ampere. Since the 100 ohms resistance, galvanometer and variable resistors are connected in series, same current will flow through all of them. So the figure of merit of the galvanometer I by theta equal to 16 into 10 power minus 5 by 10, which is 16 into 10 power minus 6 ampere per division. The resistance of the galvanometer in ohm is. Potential drop across the galvanometer is 12 millivolt. Current through the galvanometer I equal to 16 into 10 power minus 5 ampere. So the resistance of the galvanometer Rj equal to Vg by I, that is 12 into 10 power minus 3 by 16 into 10 power minus 5, which is 75 ohm. The series combination of galvanometer with a resistance R is connected across an ideal voltage supply of 12 volts, and this time the galvanometer shows full scale deflection of 30 divisions. The value of R is nearly. Full scale deflection of the galvanometer is 30 divisions. So the full scale deflection current I equal to 30 into 16 into 10 power minus 6, that is 48 into 10 power minus 5 ampere. Current in the circuit I equal to V by R series, that is 12 by R plus 75. 48 into 10 power minus 5 equal to 12 by R plus 75, which gives R equal to 25 kilo ohm. A 24 ohm resistance is connected to a 5 volt battery with an internal resistance of 1 ohm. A 25 kilo ohm resistance is connected in series with the galvanometer, and this combination is used to measure the voltage across the 24 ohm resistance. The number of divisions shown in the galvanometer is current through the resistance without galvanometer I equal to V by R, that is 5 by 24 plus 1, that is 0.2 ampere. Current flowing through the galvanometer Ig equal to R by R plus Rg, that is 24 by 24 plus 25,000 plus 75 into 0.2, which is 19.2 microampere. So the number of divisions shown in the galvanometer is 19.2 by 16 into 10, that is 12. Now a 1000 microfarad capacitor is charged using 12 volt supply and is discharged through the galvanometer resistance combination used in the previous question. The current I at a different time t are recorded. A graph of ln I against t is plotted. The slope of the graph is discharging capacitor Q equal to Q naught e power minus t by RC. Differentiating with respect to time, dq by dt equal to Q naught e power minus t by RC into minus 1 by RC, which gives us I equal to I naught e power minus t by RC. Applying log on both sides, ln n equal to ln I naught minus t by RC, that is ln I equal to minus 1 by RC t plus ln I naught, which is in the form of y equal to minus mx plus c. It is a straight line with a negative slope and positive y-intercept. The slope of the graph m equal to minus 1 by rc, that is minus 0.04 second inverse. In Newton's inverse square law of gravitation, force has some dependence on radial distance other than r power minus 2. Which one of Kepler's 3 laws of planetary motion would remain unchanged? Kepler's first law deals with planets revolving around Sun in elliptical orbits. So that is shape of the orbit. Second law is aerial velocity of a planet around Sun is a constant. It is a consequence of conservation of angular momentum. L remains constant as the torque provided by gravitational force is 0. Third law is square of time period is proportional to cube of radius of the orbit. So the second law is not going to be affected by change in magnitude of force, as a gravitational force provides a 0 torque as far as planetary motion is concerned. A neutral metal bar moves at a constant velocity v to the right through a region of uniform magnetic field directed out of the page as shown. Therefore, positive charge accumulates to the left side and negative charge to the right side of the rod. Negative charge accumulates to the left side and a positive charge to the right side of the rod. Positive charge accumulates to the top end and a negative charge accumulates at the bottom end. Negative charge accumulates at the top end and positive charge at the bottom end of the rod. Force acting on charged particle moving in magnetic field is given by F bar equal to Q times V bar cross B bar. Direction of force is the direction of cross product. Applying right hand rule, closing the fingers of right hand from first vector to second vector, thumb gives the direction of force acting on positive charge due to the magnetic field. So the electrons will move to the top end of the rod, giving it a negative charge, and the bottom end of the rod will be positively charged. So the correct option is 4. 2 moles of hydrogen are mixed with n moles of helium. The root mean square speed of gas molecules in the mixture is root 2 times the speed of sound in the mixture. Then n is root mean square velocity of the gas molecules v equal to root of 3 rt by m. Speed of sound in gas vs equal to root of gamma rt by m. Molecular mass of the mixture m mixture equal to n1 m1 plus n2 m2 by n1 plus n2, that is 2 into 2 plus n into 4 by 2 plus n, which is 4 plus 4n by 2 plus n. Effective gamma of the mixture n11 plus n2 by gamma equal to n1 by gamma 1 plus n2 by gamma 2, that is 2 plus n by gamma equal to 2 by 7 by 5 plus n by 5 by 3. Given v equal to root 2 times vs, so root 3 equal to root 2 times, from which we have gamma equal to 3 by 2. So 2 plus n by 3 by 2 equal to 2 by 7 by 5 plus n by 5 by 3, which gives n equal to 1.5. In the figure shown below, masses of blocks A and B are 3 kg and 6 kg respectively. The force constants of springs S1 and S2 are 160 Newton per meter and 40 Newton per meter respectively. Length of the light string connected to the blocks is 8 meter. The system is released from rest with the springs at their natural lengths. The maximum elongation of spring S1 will be. Change in gravitational potential energy is equal to change in elastic potential energy. So m2 minus m1 g into x equal to half of k1 plus k2 into x square, which gives x equal to 0.294 meter. Two particles A and B of equal masses have velocities VA bar equal to 2I plus j and VB bar equal to minus I plus 2j. The particles move with accelerations AA equal to minus 4I minus j and AB equal to minus 2I plus 3j respectively. The center of mass of the two particles move along. Velocity of center of mass VCM equal to m1 v1 plus m2 v2 by m1 plus m2, that is VA plus VB by 2 as masses are same. That comes out to be I plus 3j by 2. Acceleration of the center of mass ACM equal to m1 a1 plus m2 a2 by m1 plus m2, that is AA plus AB by 2, which is minus 3I plus j. The dot product of velocity vector and acceleration vector is coming out to be 0, indicating that they are perpendicular to each other. So the center of mass follows a circular path as velocity and accelerations are perpendicular. A ray is incident on refracting surface of refractive index mu at an angle of incidence I and the corresponding angle of refraction is r. The deviation of the ray after refraction is given by delta equal to I minus r. Then one may conclude that r increases with I, delta increases with I, delta decreases with I. Maximum value of delta is cos inverse 1 by mu. Applying Snell's law, mu1 sin I equal to mu2 sin r, 1 into sin I equal to mu sin r, which gives mu equal to sin I by sin r. Since mu for a given medium is constant, we can see r is proportional to I. Deviation delta equal to I minus r, I is greater than r, so with increase in I, deviation also increases. As delta increases with I, for delta maximum, that is I equal to 90, when I is 90, mu equal to sin 90 by sin r, that is r equal to sin inverse 1 by mu. So delta max equal to 90 minus sin inverse 1 by mu, that is cos inverse 1 by mu. In a series RC circuit, the supply voltage V is kept constant at 2 volt and the frequency of sinusoidal voltage is varied from 500 Hz to 2000 Hz. The voltage across the resistance R equal to 1000 ohms is measured each time as VR. For the determination of C, a student wants to draw a linear graph and try to get C from the slope. Then she may draw the graph of voltage across the resistor VR equal to I into R, that is R into V by root of R square plus 1 by 2 pi FC whole square. That implies R square plus 1 by 2 pi FC whole square equal to V square VR square into R square. Further, 1 by 2 pi FC whole square equal to V square by VR square into R square minus R square, from which we get F is proportional to VR by root of V square minus VR square. From the above equation, 1 by 4 pi square F square C square equal to 1 by VR square of V square minus 1 of R square, that is 1 by F square equal to 1 by VR square 4 pi C square R square of V square minus 1. We can further write 1 by 4 pi square F square C square equal to V square by VR square R square minus R square, that is 1 by F square equal to V square by VR square 4 pi C square R square minus 4 pi C square R square. So B, C, D are correct. Two balls A and B moving in the same direction collide. The mass of B is P times that of A. Before the collision, the velocity of A was Q times that of B. After the collision, A comes to rest. If E be the coefficient of restitution, then which of the following conclusions are correct? Velocity of B before collision is U. Velocity of ball A before collision is QU. Mass of ball A is M, mass of ball B is MP. Applying conservation of momentum for the collision, MA UA plus MB UB equal to MAVA plus MBVB. So it is MQU plus MPU equal to MP final, which gives V final equal to P plus Q into U by P. Coefficient of restitution E equal to P plus Q U by P by QU minus U, which is P plus Q by PQ minus P. Since E is less than or equal to 1, we can write P plus Q by PQ minus P is less than or equal to 1, which gives P to be greater than or equal to Q by Q minus 2. A convex lens and a concave lens are kept in contact, and the combination is used for the formation of image of a body by keeping it at different places on the principal axis. The image formed by this combination of lenses can be effective focal length of the combination 1 by f equal to 1 by f1 minus 1 by f2, which gives f equal to f1 f2 by f2 minus f1. Based on relative magnitudes of f1 and f2, the combination can be a convex lens or a concave lens. If it is a concave lens, diminished erect and virtual image is formed for all positions of the object. If it is a convex lens, magnified, inverted and real image is formed when the object is between center of curvature and focal point. Diminished, inverted and real image is formed when the object is between infinity and center of curvature. Magnified, erect and virtual image is formed when the object is between focal point and optic center. So all the 4 options are correct. In a bipolar junction transistor, the most heavily doped region is emitter. The level of doping is same in both emitter and collector. Its base is the thinnest part. When connected in common emitter configuration, a base current is generally of the order of microampere. A transistor consists of 3 regions: emitter having moderate thickness and heavy doping, base thinnest region and light doping, collector maximum thickness and moderate doping. As base is the thinnest region, very less number of charge carriers are available, so base current is of the order of microampere. So 1, 3 and 4 are correct options. A particle starting from rest at the highest point slides down the outside of a smooth vertical circular track of radius 0.3 meter. When it leaves the track, its vertical fall is h and the linear velocity is v. The angle made by the radius at the position of the particle with the vertical is theta. Now consider the following observations taking g equal to 10 meter per second square. At h equal to 0.1 meter and cos theta equal to 2 by 3, h equal to 0.2 meter and cos theta equal to 1 by 3, v equal to root 2 meter per second. After leaving the circular track, the particle will describe a parabolic path. The explanation is given in the next slide. Applying conservation of mechanical energy at A and B, EA equal to EB, KA plus UA equal to KB plus UB, that is 0 plus 0 equal to half mv square minus mgh. Here we have taken the point A to be the zero potential energy. From this we get V equal to root 2gh. From the diagram, cos theta equal to R minus h by R, which gives h equal to R of 1 minus cos theta. Writing force equation on the particle at B, mg cos theta minus n equal to mv square by R. As the particle loses contact at B, n is 0. So mg cos theta equal to mv square by R, cos theta equal to v square by rg. That is 2gh by rg, which is 2h by r. For h equal to 0.1, cos theta is coming out to be 2 by 3. Speed of the particle v equal to root 2gh, that is root of 2 into 10 into 0.1, that is root 2 meter per second. So 1, 2 and 4 are correct options. A small bar magnet is suspended by a thread. A torque is applied and the magnet is found to execute angular oscillations. The time period of oscillations decreases with moment of the magnet, increases with increase in horizontal component of Earth's magnetic field, will remain unchanged even if another magnet is kept at a distance, depends on mass of the magnet. Time period of oscillation of the bar magnet T equal to 2 pi root I by mb, where I is moment of inertia, m by 12 times L square plus b square, m is mass, L is length and b is breadth. Capital M is the magnetic moment and capital LB is the magnetic field induction. Here it is a horizontal component of Earth's magnetic field. We can see from the formula, first option and fourth option are correct. Two identical rods made up of two different materials A and B with thermal conductivities Ka and Kb respectively are joined end to end. The free end of A is kept at a temperature T1 while the free end of B is kept at a temperature T2 which is less than T1. Therefore, in steady state, the temperature of the junction will be determined only by Ka and Kb. If the lengths of the rods are doubled, the rate of heat flow will be halved. If the temperatures at two free ends are interchanged, junction temperature will change. The composite rod has an equivalent thermal conductivity of 2 times Ka Kb by Ka plus Kb. Let the temperature at the junction be T. See the diagram, we will have the solution in the next frame. For the series combination, same thermal current flows through both the rods. So we can write T1 minus T by L by Ka into A equal to T minus T2 by L by Kb into A, which gives us T equal to Ka T1 plus Kb T2 by Ka plus Kb. Rate of heat flow dq by dt equal to delta T by L by Ka. When the temperature of the free ends are interchanged, the interface temperature T equal to Ka T2 plus Kb T1 by Ka plus Kb. Equivalent thermal conductivity of the system. For series combination, we can write R equal to R1 plus R2, that is thermal resistors. So 2L by Ka equal to L by Ka plus L by Kba, which gives 2 by K equal to 1 by Ka plus 1 by Kb, which is K equal to 2 times Ka Kb by Ka plus Kb. If a system is made to undergo a change from an initial state to a final state by adiabatic process only, then the work done is different for different paths connecting the two states. There is no work done since there is no transfer of heat. The internal energy of the system will change. The work done is the same for all adiabatic paths. Applying first law of thermodynamics, dq equal to du plus dw. For adiabatic process, dq is 0, so 0 equal to du plus dw, which gives dw equal to minus du. So, in adiabatic process, work is done at the expense of internal energy. Internal energy is a state function. It depends on the initial and final states of the system and not on the process in which the gas is taken from initial state to final state. So work done is same for all the paths. Internal energy of the system decreases. So 3 and 4 are correct options. A body of mass 1 kg moves in xy plane under the influence of a conservative force. Its potential energy is given by U equal to 2x plus 3y, where x and y denote the coordinates of the body. The body is at rest at 2, minus 4 initially. All the quantities have SI units, therefore the body. Potential energy of the body U equal to 2x plus 3y. Force acting on the body F bar equal to minus dou U by dou x I cap minus dou U by dou y j cap, that is minus 2I minus 3j. Acceleration of the particle A bar equal to F bar by m, that is minus 2I minus 3j by 1 kg, which is root 13 meter per second square, which is a constant value. Speed of the particle V equal to U plus AT, 0 plus root 13 into 2, that is 2 root 13 meter per second. Velocity of the particle V bar equal to integral 0 to t A bar dt, that is integral 0 to t minus 2I minus 3j dt, that is minus 2ti minus 3tj. Displacement of the particle along x-axis Vx equal to dx by dt, dx equal to Vx dt, that is integral 2 to x, dx equal to integral 0 to t minus 2t dt, which gives us x equal to 2 minus t square. Displacement of the particle along y-axis Vy equal to dy by dt, dy equal to Vy dt, integral minus 4 to y, dy equal to integral 0 to t minus 3t dt, which gives us y equal to minus 4 minus 3t square by 2. At y equal to 0, the particle crosses x-axis. So 0 equal to minus 4 minus 3t square by 2, which gives t equal to root of minus 8 by 3, which is an impossibility. Path followed by the particle y equal to minus 4 minus 3t square by 2, eliminating time from this expression. Minus 4 minus 3 by 2 times 2 minus x, which gives the equation as y equal to 1.5x minus 7, which is a straight line with a positive slope and negative y-intercept.